hope I don't spill any of this acid on me. Oh God!
Stuart, stop! It's only vinegar!
What?
It's a weak acid!
So it won't burn me?
No!
Welcome to Crash Course. Today we're going to talk about acids and bases. You may be asking yourself what acids and bases are. As you probably already know, acids taste sour.
Oh, that's sour.
You also probably know that bases, like this soap here, taste bitter. However, due to different concentrations amongst these acids and bases, they are weak and strong.
I've been pondering. What's the difference between a weak acid and a strong acid? A weak base and a strong base.
To answer Stuart's question, strong acids and strong bases dissociate completely and go to completion. On the other hand, weak acids and weak bases don't dissociate completely and go to completion, and they establish an equilibrium constant.
So, how do we define acids and bases?
Another way to distinguish whether or not the solution is an acid or base is by using litmus paper. When you put litmus paper in an acid, it turns it red. And when you put litmus paper in a base, it turns it blue. Pardon me, but my stomach acids are acting up again. Please excuse me.
Cameron's taking a break, I'll fill in for him.
Any other ways to define acids and bases?
The matter factor is pH and pOH. The pH is concentration of H0 plus ions in solution, and the pH scale is measured from 0 to 14. 0 is most acidic, and 14 is most basic, and 7 is neutral. To find pH, you do the negative log of H0 plus concentration. The pOH, and also there's the pOH, which is the concentration of OH minus ions in solution. The pOH scale is opposite of the pH scale. 0 is most basic, and 14 is most acidic. The pH and the pOH is the same solution, both add up to 14. Also, the pH scale is more common than the pOH scale.
Where were we? I'm joining you again.
Well, we were just about to begin talking about different acid and base reactions.
Oh, wonderful. Where do I even begin?
Well, how about the basic format?
When an acid and base react, they form conjugate acid and base pairs. Let's take a simple look. Let's take a simple reaction between baking soda and vinegar. When these two solutions react, they form acetate, Na+, water, and carbon dioxide gas. Acetate being the conjugate base and Na+ being the conjugate acid. Conjugate acids always have positive charge, and conjugate bases always have a negative charge. Now, Ryan, what are some of the different types of acid-base reactions?
Well, yes, Karen, there are 4 different types of acid-base reactions. The first one is a strong acid, strong base reaction. The reaction goes to full completion. The products here usually tend to be more neutral because it's a strong acid and a strong base. And when they come together in the solution, they kind of neutralize each other. I think the pH close to 7. The second type of reaction is a strong acid, weak base reaction. And this does not go to completion. And the products tend to be more acidic because it's a strong acid, weak base. So the strong acid kind of takes over the weak base. The third type is weak acid, strong base, and this usually tends to be more basic, and like the previous one, it does not go to completion. And this one tends to be more basic because it's a strong base and a weak acid, so the strong base kind of takes over in the solution, which makes it more basic. And the last reaction, the fourth, is a weak acid, weak base, and this reaction does not go to completion because it's not a strong acid or strong base together, and that's the only one that goes to completion. When they are both weak, then they cannot go to completion. And these products tend to be more neutral because they're both weak, so it's kind of just like cancels out each other. So pH would be kind of close to 7.
What does a weak acid, weak base reaction look like?
Alright, so here's a demonstration of a weak acid, weak base reaction. So what we're going to do is going to mix baking soda with vinegar, hope we can create a boom. So first we put in some baking soda. And then we insert it to the bottom of this volcano that we made. It fits perfectly in there. And now we just gotta pour the acid and then we'll get our boom! Alright, the reaction for our volcano is acetic acid plus baking soda produces sodium acetate, water, and carbon dioxide.
This is gonna be a big one, so hold on to your seatbelts.
To perform an acid-base reaction, you need to undergo titration. What is titration, you may be asking? Well, let me tell you. Titration is a method to quantitatively find concentration of an acid or base by titrating the solution out of the bread.
What is a buffer?
Well, Stuart, to answer another one of your questions, a buffer is an aqueous solution that has highly stable pH. So if you add some acid or base to the overall pH, will not change significantly.
So, how do you make one of these buffers?
Well, Stuart, you do this by mixing a large amount of weak acid or weak base with its conjugate acid plus base. And the best buffer is when the concentration of acid or base equals the concentration of the conjugate acid or base.
So, what is a neutralization reaction?
Another question, sir? I thought you were in AP Chem. Well, I guess to answer your last question, a neutralization reaction is when an acid and a base react to make a salt.